So as we have started the topic architectural design, inside this architectural design, we have seen in the last presentation about the software architecture, and let me have a look for today about architectural styles. Before going to the architectural styles, let me have a discussion of this what we have discussed in the last presentation. Software architecture, what is architecture, why it is important, and what will be the description will look like, means the output of software architecture look like, and what are the decisions yes can take in. So simply an architecture of a system is a comprehensive framework that describes its form and structure. And the definition of software architecture is the structure or structures of the system. It will be both called as structure as well as structures of the system. Structures of the system. Now, in this structures of the system, it compresses with software components as well as it will be external visible the properties of that components and relationship among that component. So simply a software architecture is the structure or the structures of the system which compress software components, the external visible properties of those components and relationships among them. And we also seen the main thing which is going to be have in this architecture and the three key reasons why this architecture is important for communication and understanding, and we can give a highlights of early design decisions. We can constitute a model before going to the actual design. So an architectural description will be considered as a mental image in a simpler way we can say, and this mental image can have a implication or imagination for stakeholders to see that how the product or how the software will be look like in the different viewpoints. Okay, and simply an architectural description is actually a set of work products that reflect different views of the system. Okay, now this is a graphical representation of the architectural description where it starts with the stakeholder, from here. It goes on based on the system concern and the purposes what we required, and with the help of the system environment, focuses on architecture. And finally, the output of this architecture will be considered as the architecture. And the decision making over this after completion of the architecture will helps to develop each view of the architectural description as a whole. And if it is good looking of the view, we can make the same, or else we can go for a variety of alternatives and make some ultimate decisions over there. So this is one template for architectural description decisions, like it consisting design issue, resolution, category, assumptions, constraints, alternatives, argument, implication, related decisions, related concerns for products, nodes, all sort of these components will be available in this templates. Okay. Now, coming to the actual topic of today, that is architecture styles. So, software architecture and architectural styles is the part of architectural design. Don't we forget about that. Okay. Now, let me have a look over here. This look architectural styles. Simply, this are different ways of styles we are having. But among that, as per the syllabus, we are talking about a 5 different types of architectural styles. The first one talks about the data center architecture. The second one talks about data flow architecture. Third one talks about call and return architecture. The fourth talks about OO architecture, object oriented architectures. The fifth one talks about the layered architecture. Let me have a look of each one style in this class. Now, before going to start the types of architectural styles, let me have a look of what actually architectural style means. Like in the previous presentation, we have seen the definition of architecture, the definition of software architecture, the definition of architectural description. Now, let me have a look of this architectural style. Architectural style is a transformation that is imposed on the design of an entire system. Now, it look like as the transformation of the entire that is imposed on the design of an entire system. The meaning indicates that however you the design will look like, after the architectural description, how the style will look like. So that transforming that into whatever the entire design, transforming into a particular style will comes under architectural style. In a simpler manner, the main objective or the main intent is to establish a structure for all the components of the system. Establish a structure in the sense, establish a look for that, and it shows you in a different ways. So the main intent of this architecture style is establish a structure for all the components of the system. Now let me have a look what actually it describes. Means each style describes what? Each style describes a set system category that encompasses with set of components, set of connectors, set of constraints, and finally semantic models. This all four will be compressed, describes in each style. How many number of components are available? How many number of the connectors are available? The purpose of connectors is making communication and coordination. And what type of constraints? How these components are going to be integrated to form the system? Means to connect one component to another component, what is the minimum constraint to satisfy for that? Next, we'll talk about the semantic models, which understand overall. Means semantic model means it overall the properties of a system. It will define in this semantic model. So each style will describe its set of components, set of connectors, constraints, and semantic models. And coming to the architectural pattern, architectural patterns also be is as a prerequisite to understand the styles of this pattern. Okay. So an architectural pattern, like an architectural style, different in number of fundamental ways. Meaning of here is style and pattern will have a differences over there, because if you think about that, pattern and style both are not same. There is some different in number of fundamental ways. Like the scope of the pattern is very less because the pattern means only a less size in case, whereas the style, the scope of that style is a more. A pattern imposed a rule on the architecture and how the software will handle some aspect of the functionality at the infrastructure level. Based on the rule based on the architecture, a pattern will act. Meaning here is we have different types of patterns are available, but it is not available in the syllabus. We have creational patterns, we have structural patterns, we have behavioral patterns. These three type of categories of patterns will work based on the suitable. Means on an average, we have 28 plus different design patterns are available, among which depends each pattern will work based on a rule. But here the style, it doesn't like that. And the third difference is the architectural patterns tend to address specific behavioral issues within the context of the architecture. Meaning here is how real times applications handle synchronization or interrupts. Now it will depends on the address specific behavioral issues. That is another constraint, another difference between a architectural pattern and architectural style. Now coming to the types of architectural styles. The first one, data center architecture. Let me have a look for this data center architecture. The name itself talks about it is a centrally monitoring and acting as a center of processing the data or sending some sort of data from one node to another node. Let me have a look of this data center architecture. It promotes integrability. So it promotes integrability in the sense it will easily add any new components to the existing one. So existing components can be changed and new client components added to the architecture without concern about other clients, without concern about other clients, means without disturbing other. So like client components operate independent. So for an existing components, easily we can change it, easily we can integrate it, easily we can replace it. If you are doing that one, then it is the main definition of integrable, right? So integrability will be added over there. As a graphical representation of this data center architecture, we have different client softwares like client software 1, 2, 3, 4, 5. different. At any point of time, based on our requirement, we can change any one of this client software. That is centrally, it is a repository as a Blackboard. So Blackboard is a type of the architectural style name. So you can maintain in this data store, it maintains a repository or a Blackboard. So with the help of that, easily they can apply the integrability, easily can change this. So that's why there is a bidirectional symbol between these two. It is not a single dimension directional, bidirectional. At any time we can add over there, we can remove and do some sort of two-way communication. Okay, two-way communication over there. And coming to the second one, what is the second one? Data flow architecture. Data flow architecture is the second one, right? So coming the name itself, data flow, the flow of this one, show the flow of the input data and how your components are computationally doing and generating the output. In a simpler manner, input, process, output. Here input here, input data, process means computationing the components, and output. Output means presenting that. So what type of style we can use inside? Like in the previous example, previous graphical representation for data center, it is using Blackboard style. Now they are going to using here pipe and filter. The pipe in the sense it is going to have a pipe over there, and we can make have some filters we can apply here. We can apply some sort of filters over here. Based on that input, it will be filtered and it will give some sort of output here. Okay. So structure is also called as here pipe and filter. So pipe provides the path for flow of data. Pipe in the sense for like water flowing of that, we are using pipes in the same manner. Here, the bus is going to be using internally inside the computer. Now here pipe indicates the path for flow of data, and filters manipulate the data and work independently of its neighbor filter, right? Neighboring filter, based on that, it will be manipulated. And if you want to manipulate, definitely we have to be apply the filter. If data flow degenerates into a single line of transform, it is going to be termed as batch sequential. In the sense, if you are going to be dealing with only one part of that, it will talks about batch sequential. The data flow degenerates into a single line of transform. This term as batch sequential. Okay, and see the graphical representation of this data flow architecture. Like as I said, it is also be called as pipe and filter. Now between the filters, here different filters are there. Filter 1, filter 2, filter 3, 4, 5, 6, 7, 8. Here 7, it is 8, this is 8, 9, 10. 10 filters are available over here, right? So these 10 filters to communicate between to each other to manipulate the data. The arrow marks internally, the connectivity between the filter to filter is called as pipes. If you make that combination, it will be called as a pipe and filters. So pipe will be act as a path to flow the data, whereas filter is going to be make some manipulations or make the some sort of the filterings can be done, and whatever the needed or necessary things is required, that will be considered into picture, right? That is the second. Coming to the third one, called and return architecture. If you remember the functions concepts in Python, if you clearly, we are going to be calling a function. After calling a function, that function will compute something and return it. Maybe few functions doesn't return anything, few functions return something. In the same fashion, here call and return architecture also doing the same thing. How means it achieves a structure that is easy to modify and scale. It is going to using two substyles. One is main program or subprogram. Second one RPC. RPC stands for remote procedure call. Now the first architecture, first style, data center architecture using Blackboard style. The second data flow architecture using pipes and filter. The third call and return architecture going to using two substyles. The first one, main program and subprogram. Second one, RPC, stands for remote procedure call architecture. Now coming to the main program subprogram, just apply your Python program which is having the function. Like in the main, we are going to be calling that function. So classic program structure, main program invokes a number of components. Invoke means what? It will calls the different functions. Different functions we are going to calling over there. Now here function you can apply in the Java as method, that you are going to be calling that method with the help of object name dot method name. Invoking means calling that method, calling that function, number of components, which in turn in the sense after doing computation in the definition of that function or definition of that method, in return it invoke still other components. It is again going to be calling and returning something. So like this, the main program having a subprogram, again a subprogram having another subprogram. Like this, recursively there is a number of programs, subprograms will be there, or each program will in turn return some sort of computational for that component. Here, component can be considered as a definition, or component can be considered as a parameters to compute that one. Whatever we can consider as a component over here. Coming to the second substyle in call and return architecture is RPC. So this RPC, remote procedure call, components of main and subprogram are distributed across components over network. So this and this, where it differs means this is locally run. So this RPC, the name itself, remotely run that procedure call. Procedure call means what? Again, it is a main and subprogram. So previous substyle, that is main program and subprogram, will be compute, will be make some sort of things in the local. But RPC also be a similar to the main program and subprogram. But the difference between the first substyle and second substyle is to compute that one, it will be distributed across computers or network. Distributed across our network, it will distribute. Means the subprogram to compute it, it doesn't depends on the local machine. It will be sent to the remote so that the remote, whoever have the different free or ideal, that system will be compute that one and return the results over. So in that fashion, it is comes under main program and subprogram, and remote processor call will comes under call and return program, return architecture. If you see as a graphical representation of this main program and subprogram architecture, closely observe, this is a main program. Again, it is a having a two controller programs, two controller subprograms over here. This is controller subprogram. This is another control subprogram. Again, this control subprogram is divided into application subprogram. Again, it is dividing into 2.1. Again, we have different, right? And again, this controller subprograms again divided into application program 3.1 and application program 3.2. Like this, we can have a different from the main program. A subprogram will call. From that subprogram, another subprogram will call. That subprogram again subprogram will call. Like this, one after the other, calling and returning, calling and returning, calling and returning. This type of architectures will comes under this architectural style. Coming to the fourth one, like we have started here. This is the fourth one, object-oriented architecture. In this object-oriented architecture, the name itself talks about OO. Whatever the features of object-oriented, like we have encapsulation, polymorphism, inheritance, all sort of things will be done with the help of this OO architecture. What will we do in OO architecture? Let we have a look. The components of a system, it will be encapsulates. Encapsulate means what? Both the data and the computing things will be integrated. Means the data and the operations are going to be integrating, combining into one, like as a capsule, right? Combining into one, and it will be sent between the one another to neighbors. The communication coordination between the components done via messages. So here, this object-oriented architecture deals with perform this encapsulation. And with the help of this, it will communicate and coordinate between the components via messages. How the message will be encrypted? Like as a capsule. How it is encrypted? The caps will look like separate. Two different things will be there in the capsule. Same like data is one, Another is the operations. Both are going to be encrypted and sent via the messages. And the last one is layered architecture. So in this layered architecture, the last type of architectural style is layered. Layer here in the sense is one region, is one part of that, one region to region, moving from one location to another location. We have different, normally a system or a application to develop it, we required a three-tier architecture or three-tier layer. What the three layer in the sense? When you want to be interacting with the system, we want first of all a database, means at the bottom we require a database, middleware and application. So application layer, middleware, and the last we can call as backend layer or we can call as bottom up layer. Top, middle, bottom. Top layer is nothing but what you are going to be viewing now. What the screen you are going to be viewing, that is called as top layer. That is called as outer layer. Simply, top layer is called as outer layer. Intermediate is nothing but middleware. How you are watching that with the help of how you are viewing the screen, maybe through mobile or through the laptop or desktop, with the help of a middleware. What is the middleware you are going to using here? It is a laptop or a mobile. It is again an intermediate layer which you can view that one. Now, only laptop or desktop or mobile and person is not enough. We required another. We required another a bottom up layer where it will connect you. How this mouse will connected to your system, how your keyboard is connected to your system, how your printer is connected to your system, how your scanner is connected to your system, how your mobile is connected to your system. Once it is connected, whatever you are doing over there, how you are talking with your keyboard, how you are operating your mouse, and how it is knowing that whether you are moving left, right, or whether you are moving right symbol or left symbol, left press or right press. What how will know? We require an interface. That interface here called as OS. So any layer consisting of three layers: the top layer, middleware, and bottom. Top layer is viewing, that is user interface. Middleware is any layer, utility, or application function which will interact between the top layer and bottom of layer. And inner layer means bottom layer to make communicate among this all the components. We require an interface, that is inner layer interface. So inner layer, intermediate layer, outer layer. Inner layer means interface with OS. Intermediate layer in the sense some services, some utility services and application functions is required. Outer layer is user interface. Okay, this three layers will let me have a look into as a graphical representation. If you observe this figure carefully, here the total, the total figure look like as the total layers. Here in the top, that is in top of this one, we have a user interface layer. And the second, we have application layer. The third we have utility layer, right? And fourth, the last bottom, that is core layer. So this utility layer, application layer, user interface layer. The boxes which you are looking here, this boxes talks about, this boxes talks about this one, this one, this boxes inside. It will be showing there is called as component. The each box is showing as a components. Now this core layer is the part of the internal. The heart of the computer is kernel, right? The same fashion, the core layer. On top of that, we have a utility layer. On top of that, we have the application layer. On top of that, we have the user interface layer. This graphical representation figure shows you how a layered architecture is look like. Okay. So in this class, we have discussed about the architectural styles. Under that, we have discussed the definition of architectural style and what a style will be describes and what is the difference between architectural style and architectural pattern. And the first type of style is data center architecture. Second type of style is data flow architecture. Third flow of data architecture is call and return architecture. Fourth one, object oriented architecture. And the last one, layered architecture. That's about the architecture styles.